Hello again, Tom from EveryStepCalculus.com, EveryStepPhysics.com. Because of the times I want to do this, if you send me $10 via PayPal to buy my programs, and you send it to my personal email of tomtrumpet4@gmail.com. That's TOMTRUMPET, the number 4, at gmail.com. And I'll send you the latest updated programs with instructions. It's over 750 of them, and for your keeping and use, and plus you still get my help to pass calculus or physics, whatever you needed. Okay, so $10 to my PayPal and you can buy my programs. Okay. Also, if you feel like it, maybe share this video with somebody else or in your class or whatever, and maybe subscribe to my site so that you can see other future videos I might produce. Now, this problem here, this is involved with graphing an ellipsoid. Ellipsoid is the shape of a chicken egg, 3D version, and of course an ellipse is just a 2D version of an ellipse, like a orbit of a planet around another planet or the sun or something. Okay. Notice that calculus has nothing to do with this stuff here. There's no derivatives or integrals, no finding areas or volumes or anything. So it's just, knowing what to do and how to get to decipher the terms out of this equation here, which is a standard ellipsoid equation. Just a couple things, main things about ellipsoids. The largest denominator term under the x term means it's a horizontal. The axis is the major axis is horizontal. Okay. And then like this one, the main denominator is under the y term, so that's vertical. The major axis is vertical. Now if you're going to graph one of these, since these points all look the same on any ellipsoid as you graph it, if somebody asked you to graph an ellipsoid quick, you first know that it's horizontal or vertical, depending upon where the denominator term, the largest denominator term is. And then just draw an ellipse like this. Just draw the circle. And you're going to have the vertex outside. You're going to have the co-vertices on the short width. You're going to have the center in the middle. And after you do that, then you can figure out what this after the center where the 0, 0 origin is on the graph, which is right here, x and y. Okay. So draw the diagram first, the ellipse circle first, and then put in the points as I show you how to do it on my programs. And this would be a vertical one, so do that first, and then put the points in. You got to have the center, etc. So let's do that with my programs. I'm already at ellipse here after I type in index 8 and go to my main menu. And we're going to find the graph of the ellipse, so we're going to choose number 2, and we're going to enter the equation. Now I ask for these separated because if I put the equation in, which I did when I originally started to program this stuff, but the calculator automatically will reduce things and factor things and make it more compatible to mathematic, things. So I need to enter them separately, the first one and the second one. Okay. So we have to press alpha first, so we're going to go left parentheses x plus 4 squared divided by 20. I always show you what you've entered so you can change it if you made a mistake. I say it's okay. We're going to enter the second one. Alpha again, left parentheses, y minus 3 squared divided by 6. And that's okay. Does the equation equal 1? Yes, it does. The reason I ask you that is because there's a lot of equations which you'll have 100 over here or something, some other term, and then you got to use, which I do in my program, you got to change this back to a standard equation, so you have to do certain algebraic things to do that. So now that we know it's going to equal 1, here's the what you've entered. I say it's, yep, this looks pretty good. Here's where I find out whether this is larger or not, and so then I know whether it's a horizontal. This happens to be a horizontal orientation for this ellipse because the major axis is horizontal. And there's the formula for it. So write this stuff on your paper. Remember that calculus and physics tests are scored on partial credit in the class curves. So whatever points you can throw down on a test problem gives you certain points. I remember one time I got a 26 on a physics test and got an A in it. I thought I flunked it, but I got an A in it simply because I had more points than somebody else in the class, you know. So then we find out the A, B, and C of it. Square root of 20 is 4.5. Square root is 6. These are A squared and B squared, so etc. And then C is A squared minus B squared, square root of that, 20 minus 6, square root of 14 equals 3.7. We use these to find out the different foci and vertices and covertices. So here's the center, minus 4 and 3, right here. You notice how you change the sign on these. If you see x plus 4 is right away, you know that minus 4 is in the x position. And here's minus 3, so you know right away that plus 3 is in the y position. And then we're going to find the foci, which we take h plus c minus 4 plus 3.7 equals minus 7.7 and 3. And here's the y term, etc. And we do the same thing with the vertices. And I do all that for you because we don't have time to in a test to worry about this stuff. Just get it down and get past your test. I do show you the upper half of the ellipse with the terms put in there so that you can check it yourself. Here's the two focus, minus 7 and 3 and minus 0.26 and 3, two focuses. Then I show you the bottom focus and where they are, what they are. Here's the center, minus 4 and 3. Here's the way it looks. And here's the covertice. Okay? So let's go back and change these now. Let's do another one. Let's put in this equation here. Okay, so alpha x plus 4, we're just going to change the squared divided by 6 on this one. We're going to enter the second term, which is alpha y minus 3 squared divided by 20. And that looks pretty good. Equation equals 1, yes. Now we know that it's vertical because the large denominator is under the y. And here's the formula for the vertical ellipse. Here's the terms, essentially the same. Center is at -4,3. Foci is, this will change now because it's vertical rather than horizontal. Here's the vertices. Here's the way it looks with the vertical. Here's the center. Here's the focus on the upper half. And here's the co-vertices here on the sides. And then the bottom one is here. Here's the vertex in the bottom. Pretty neat, huh? EveryStepCalculus.com. Go to my site and check out my other programs. But in this case, remember to, if you want to buy them, send me $10 on my PayPal email, and I'll send you the programs, and you'll pass calculus or physics. Buy either one. I'll do the what for either one. Okay. Good luck in your classes, and I'm all for you passing and getting out of there, never to touch this crap again. Okay. So, anyways, have a good one.